After calculating the length of the spring and the thickness of the spring, we want to calculating the second part. So it's nothing but deflections. So how the spring can be enlarged due to the weight. So that's why we can calculating the deflection of the spring. And finally we can conclude this each length of the leaf springs. Now we can calculate the deflection of the spring. Deflection, it is denoted by y. So the formula begins is y is equal to 12 PL cube divided by PT cube E into 3NF plus 2NG. So in the particular formula, so load, length, breadth, thickness, it is nothing but E is nothing but an Young's modulus. So particular problem there will not be given. So we can directly assume it as Young's modulus is equal to 21 into 10 to the power of 3 Newton per mm squared for the material, suitable material. So we can assume with the help of PSG standard data book. So we can substitute, so NF is nothing but a full leaf, NG is a gratitude leaf. So total leaf we can add it. So y is equal to 12 into, so total load is equal to 2.7 into 10 to the power of 3 into L is nothing but an 482.5 the whole cube divided by B is nothing but a breadth 33.3 into 8.34 into 210 into 10 to the power of 3 into 3 of total fringe 2 plus 2 of 10. So we can summarize this value. So y is nothing but 34 mm. Could you cross check with this? So this is called as deflection of the leaf spring. So final conclusions, we can go with the each number of leaves. So n is equal to 12 directly given. So we want to calculate L1 to L12. That is called as each number of leaves. So the formula behind this, length of the each spring, L1 becomes 2L divided by n minus 1 into 1 plus bandwidth. So 2L is already we know, the value becomes 965 divided by total length is equal to number of spring is equal to 12. So 12 minus 1 into 1 plus 85 mm. Why I will put here 1 is equal to, the suffix is 1, that's why we are multiplied with the 1. So final answer becomes L1 is equal to 172.4 mm. So parallelly we can calculating the up to 12, L12. So now one example is equal to 2 is equal to 2L minus divided by n minus 1 into 2. Now becomes the interchange, here is 1, now here is 2 plus the bandwidth. So same 965, 12 minus 1 into 2 plus 85. So the value becomes 248.5 mm. This is called as L2. Next we want to calculating L3 up to we want to calculating the L12 because the number of spring is equal to 12. That's why we can calculating the L12 itself. Any doubts in this regarding? So in the second half you can concentrate on the most in the leaf spring. Compared with a helical spring, the leaf spring is more difficult to design the part. So everybody to look on it into the leaf spring itself because helical spring is the only nothing but, I am imagining like this. So this is called as helical spring. So this is called as major dia. This is called as coil or wire diameter. This is called as length. So this is called as fully completed spring index. So number of the revolutions completed, that's why we can calculate as a total number of things. So compare with the helical, it can be a difficult one for making the design constraint. So kindly make a practice of the leaf spring itself. Thank you all. See you on the next video.